Think about the things that happen around your house every day, leaving a carton of milk out in the summer heat, or watching an iron tawa slowly turn orange with rust. Even the way your body breaks down a meal is part of this process. In all these cases, the original material has done more than change its shape. The iron on that gate has fundamentally altered its identity to become something new. Chemists call this specific type of identity change a chemical reaction. Even though the iron looks like it is disappearing under that layer of rust, nature is not making matter vanish into thin air. It is simply taking the pieces that were already there and clicking them into a new arrangement. We can see this rearrangement in action with a classic experiment, burning a small ribbon of magnesium metal. When you heat the ribbon, it burns with a dazzling white flame and leaves behind a pile of fine white powder. This happens because the solid magnesium is grabbing oxygen from the air and locking it into its own structure. There is a specific name for a substance gaining oxygen: oxidation. If a substance were to lose oxygen instead, we would call that reduction. We refer to the starting materials, the magnesium and the oxygen, as the reactants. The newly formed white powder is our product. Every chemical reaction is the story of reactants turning into products. But to see how that happens without any pieces going missing, we need a way to count the individual ingredients involved in the transition. Since writing full sentences for every reaction is slow, chemists use a symbol-based shorthand instead. Shorthand: Mg plus O2 results in MgO. Each symbol represents a building block. You cannot create or destroy pieces. Drawing a dividing line, the blocks on both sides must perfectly match. But look, we start with 2 oxygen blocks, yet the product only has 1. Physical matter cannot simply disappear. Because the counts do not match, this equation is currently a broken instruction manual that we need to fix. With the hit and trial method, we draw rigid boxes around Mg, O2, and MgO. We can only add whole boxes. Adding a second MgO balances oxygen, but unbalances magnesium. Adding a second Mg to the left fixes this. 2 Mg plus O2 yields 2 MgO. This balancing process is how chemists prove that nature is following the rules, ensuring every single atom from the start of the reaction makes it to the very end. Our equation is now balanced, but a complete instruction manual needs one final layer of detail: the physical state of each substance. We use 4 abbreviations: S for solid, L for liquid, and G for gas. Finally, there is AQ for aqueous, like blocks floating in a pool of water. When we slide these into their correct positions, our magnesium equation is finally complete. This string of symbols is now a clear story. 2 solid magnesium blocks snap together with a paired oxygen gas block to create 2 solid magnesium oxide blocks. From the rest on a gate to the cells in your body, everything is made of these same pieces, forever clicking into new arrangements.